I would like to use this example to explain how you find the odd length of a parametric curve. So we have a parametric curve. So this one, I'm going to erase this really quick. So what we have right here is I have a parametric equation, x equals to phi cosine t minus cosine phi of t. Y, we change the sign, we change the cosine to a sine. Okay, we have x equals to in terms of t, y is in terms of t. And then in the previous video, I explained how you use a graphing calculator or a decimal to sketch the graph of a parametric equation. And then the graph of this parametric equation is this curve in red. Just follow the red color. And I also, in green, a circle center at 0, and then the radius is 4. So you should know what the formula is. You are talking about standard equation of a circle. That is also in that video. The equation of a circle, center at 0, 0, and then the radius is equals to 4. Okay, and then we also have a blue circle that is a center at phi 0. The radius is equals to 1. So what we are going to do right now is I have a green circle, and then I have a blue circle, and then I will take this blue circle, okay? Take this blue circle right here, and then we start rolling. I will just roll this blue circle around the circumference of a larger circle, which is the green circle. And then after you finish the rolling, so once the circle start rolling, the point you will see that there is a trail that looks like the parametric curve of the red parametric equation. So what we are trying to find is, hey, what is the length of this odd? So the odd length of a parametric curve is right here. So you have to go from t goes from a to b, and then the derivative of x and y with respect to t. So you have x in terms of t, y in terms of t. Take the derivative first and then square the derivative. So you may need some time to write down the problem and then set up the curve. You can always pause the video, do the writing first, and then you resume the video. And then now we are finding the derivative. Okay, dx dt, where is x? X is right here. So we are taking the derivative of cosine. The derivative of cosine, so dx dt, the derivative of cosine is negative sine. So I have a negative phi sine of t, and then a minus. This minus is from the parametric equation. The derivative of cosine is minus sine, and then I have a phi t. By chain rule, the derivative of phi t is equals to phi. So this phi is from chain rule. I will write this out in case you don't remember. So we have a minus minus. We will take care of that in the next step. And then dy dt is right there. The derivative of sine is cosine. Then I have a phi cosine of t, and then minus from the parametric equation. The derivative of sine is equals to cosine. So that is a cosine phi t, and then by chain rule, when you take the derivative of the inner layer, you can consider this as a composition function. The derivative of phi t, that is equals to phi. Okay, moving on to the next step, we will square the derivative. Okay, let's do a dx dt. Let's do a dx dt. So I will do a dx dt, and then we square that. So that is equals to negative phi sine of t plus phi sine of phi t, and then we square that. So to help yourself, I know it is wrong to just put this right here. I will just put here temporary, so you can just multiply this like that, so we can see it very easily. All right, and then after we are done, I will erase that. So that is equals to negative phi, just a 25 sine square of t, and then negative phi negative 25 sine t sine phi t, and then phi negative phi, that is a negative 25 sine phi t, and then sine t. Phi 25, that is a sine square phi t. Okay, sine square phi t. All right, and then let's do the dy dt square, and then moving on to the dy dt square, that is equals to dy dt, that is a phi cosine of t minus phi cosine phi t, and then square. Okay, let me just erase that so that won't confuse you when you review the notes. Okay, we will do this square, and then for my convenience, I will just duplicate this one more time to put it right here so I can easily keep track of this, right? So you multiply, 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 and then you multiply. Am I right? Okay, phi, that is 25 cosine square t, negative 25 cosine t, and then cosine phi t, and then negative phi, that is a negative 25 cosine phi t, and then cosine t. Negative 5, that is a 25 square cosine, oh no, not 25 square, 25 cosine square phi t. Okay, we are going to add them, right? So according to this, let me, I think it is helpful to just, let's see, because I don't want to use the same highlight twice. So here, so this is an add, right? So I am going to put a little highlight right there, and then I will say, so we will add them. Okay, can we just take some advantage right now of some formula, just some like what is that called again? I keep forgetting this name, Pythagorean identity. So this one we can do a sine square plus cosine square, and then this one we can do a sine square plus a cosine square, and then the negative 25 can subtract the negative 25, and then the negative 25 can subtract this negative 25. And then what we are going to do next is here. So I will just make a note. So this one I will just do an example. So 25, no, that is too bold. This is 25 sine square t, and then plus 25 cosine square of t. I will factor out a 25, and then sine square plus cosine square. Sine square plus cosine square, don't tell me you don't remember. This one you cannot forget. It's equals to 1. So that is 25 times 1 equals to 25. So that applies to here and then here. Am I right? So we have a 25 plus 25 for the blue highlight and then the pink highlight. And then the rest, this will be a negative 50. This will be a negative 50. Okay, then we will just write the result. So this one, that is equals to 25. And then this one is also a plus 25. And then in the middle, I have minus 50 sine t sine phi t minus 50 cosine t cosine phi t. Okay, everything looks good. And then the 25 plus 25, I can do a 50. So this one, I will just do a 50, and then the rest, okay, I can easily duplicate that, but you may take time to handwrite this on your paper. And then don't forget that we have a square root. What square root? Where is the square root? We have a square root in here. Do you see that? We have a square root. We have a square root. Do you see that? Square root. This is part of the arc length formula. So there is a square root. And then now I will just, can I write like that? We will be taking the square root of this. And then what I am going to do is I will just take the 25 out. So just take the 25 out like that because the square root of 25 is 5. And then I have 5 minus 5 sine t sine phi t. And then another 5 cosine t cosine phi t. The square root of 25 is equals to 5. So I will put the 5 out. And then inside, did I make any mistake in here? That is definitely not a 5. I'm sorry, that is such a silly mistake, right? It's a 2. So this is supposed to be 2, a 2, and a 2. Okay, how about this? The square root, I still have a square root for the rest. So how about this? I will just do a 2 minus another 2. I factor these 2 out. I will do a sine t, sine phi t, and then minus cosine t, cosine phi t. Why are we doing this? This one we call a difference angle formula. Difference angle formula. That's why I picked this one as an interesting example for discussion, that review your difference angle formula, that also review your sine square plus cosine square. Okay, what difference angle formula? This one fits perfectly. They have a cosine a minus b. Before I write the other side, there is a a plus b, and then there is a sine a minus b, and a sine a plus b, a plus and minus. 2 for cosine, 2 for sine. So for sine and cosine, each of that has a plus and a minus. Also for tangent. But the tangent one, I don't think that is a popular. Is there one for tangent? I'm going to do a quick check really quick. Okay, this one, difference angle formulas. All right. Sine and cosine, yes, there is one for tangent. I was right, but the tangent one isn't very popular unless you are taking a course in trigonometry. Okay, this one, back to our business. Cosine A, cosine B, and then plus sine A, and then sine B. Oh, by the way, after you factor out a minus, this becomes a plus. This becomes a plus. And then what is my A, and then what is my B? So can I say my A is equals to T, A is equals to T, and then B is equals to phi T, and then A minus B is equals to 1 minus phi is negative 4T. So therefore, we have a cosine negative 4T, but that is not the end. Cosine sine, and then, not cosine sine. All the trigonometric function has an even and odd properties. What is the best way to memorize this? Just repeat after me. Just repeat. Just say one sentence to yourself. Every time you are asked to use the even and odd property of the sixth trigonometric function, just say this out loud with me. Only cosine is even. Can you say that? Only cosine is even. Just say it. Say it to yourself. Only cosine is even. Okay, cosine is even. That means that is equals to cosine of 4t. The even function will just swallow the negative. And then what about the rest? Cosine is even, then secant is even. Because secant is the reciprocal of cosine, then everybody else is odd. That means if this is a sine of negative 4t, then that is equals to negative 1 times sine of 4t. For the odd function, you can take the negative out to the front. Okay, so after all this step, we are still not in the integral yet. Phi and then the square root of 2 minus 2 cosine 4t. Cosine 4t. Can we go any further? This one, don't forget that we need to do a definite integral for the arc length formula. This one, if you just start right here, there is no way to integrate this integral. So that brings us to another formula that is called double angle formula. Double angle formula. Okay, I have a cosine 2x equals to 1 minus 2 sine square x. And then why are we using this? Because this one has a square. There is a good chance that using this one, I can get rid of this one. I can get rid of the 2 and the minus 2. And then they have a 4t. Okay, then cosine 4t, you double up the 2, then you only double the angle. 2 sine square, you are not touching this. The double of x is 2t, not 2x. Okay, you can use x, okay, but when you put it back, then you use t. You double the number in front of x, and then you go to the right hand side of the formula, you double the number in front of x. That is the end story. Don't touch the 1, don't touch the minus 2, don't touch the square. Okay, let's put this back to the red. And then this is a 5 square root 2 minus 2, and then you have 1 minus 2 sine square 2t. And then work out the math. What do we get? We have a 2 minus 2 plus 4 sine square of 2t. The 2 minus 2 is gone. Then you have a 5 square root of 4 sine square 2t. Take the square root of that, and then you have a 5 times square root of 4. Square root of square is sine 2t. And then this is the integrand. This is only the integrand. That is only the integrand. So what we are going to do right now is, allow me to go back to the graph. I am going to copy this. Do I have enough space to duplicate? Maybe. So I can shrink this a little bit. Okay, that works. So what we are going to do is, I am going to just set up an integral. Just find 1/4 or 1 quadrant, and then find one piece, and then I will multiply by 4. So I will just say within the first quadrant, and then in your unit circle, the t goes from 0 to pi over 2. This is in quadrant 1. And then the arc length is equals to integral. T goes from 0 to pi over 2. And then I have 5 times 2 sine of 2t. This can be integrated very easily, but with the square root, you can't do it. The integral of sine is negative cosine. I'm not touching the 10. And then I have, let's put the negative in front. Cosine 2t. And then when you take the derivative to get back to the integrand, there is a 2, right? By chain rule. So therefore, I need to prepare a 1/2 in front. Another way to do this is using the U substitution, but I don't think you, up to this point, you should have finished studying all the integration technique. You are able to do this without using a U substitution. You can use it, but to meet some standard, you are supposed to be able to do it without U substitution. Once again, I prepare a 1/2 in front of cosine, because when you take the derivative to go back to the integrand, the derivative of 2t, that is a chain rule that creates a 2. That's why we need to put a 1/2 in front to get rid of the 2. Such that t goes from 0 to pi over 2, and then I have a negative 5 cosine 2 times pi over 2, that is a pi, and then minus negative 5 cosine 0. Cosine of pi is equals to negative 1. Negative 5 times negative 1 minus 5 cosine 0 is equals to 1. So we have a 5 plus 5 that is equals to 10. So that is the length in quadrant 1. And then you multiply by 4. So the circumference or arc length, that is 10 times 4. The total is equals to 40. So if you answer these questions online, yeah, you do all this work. Look at this. Starting from this page, you do all this work, just for 40. Okay, so that is the end of this discussion. Hopefully that is helpful. If this is something that you would like to watch, give me a thumbs up. Subscribe to my channel for more math contents like that. And as always, I will meet you all in the next video for more lessons.